Welcome to Math with Jakara Lewis, and today we are going to simplify radicals without a coefficient. That means that it doesn't have a number in the front or what I deem as the outside. So of course we are going to kiss it. We're going to keep it super simple, and we're going to knock this down in 3 quick and easy steps. So anytime they're asking you guys to simplify a radical, our focal point is going to be the number that's on the inside, and we're going to factor this down. So you definitely have to have some skills with factoring numbers. I would recommend using a factoring chart if you can, to make it easier. So when we factor this particular number down, right, what we're looking for is a perfect square root. All right, so if I list the factors of 20, I have 1 times 20, I have 2 times 10, and I have 4 times 5, right? So we're trying to figure out of all these values, which one of these is going to be a perfect square root. Now I know 1, of course, is a perfect square root, but we want to pick a value that's outside of 1. So in this case, it's going to be 4, right? So this is going to be the factor pair that I'm going to use, 4 and 5. So when I rewrite, I'm always going to rewrite my perfect square first and then the pair second. So it makes it easier to simplify. So we're going to say the square root of 4 on the left and the square root of 5 on the right, right? All right, the next thing we're going to do is we're going to rewrite this using multiplication. And then we're going to simplify. All right, remember the first value is always the perfect square, which means it should always come out to a whole number. So well, technically in this case, it'll be a whole number. So the square root of 4 gives us 2. All right, I'm going to say 2 times the square root of 5. Now, anytime you have a whole number times a root, you can just stick them together and you can remove the multiplication symbol. So essentially, it would be 2 root 5. And that's how you simplify a radical without a coefficient. So if we go back to the top, the easiest thing to do is to list the factors. Of course, if you're well versed in the factors, you don't have to do the list. Based on that list, you want to choose the highest perfect square root. In this particular case, it's the number 4. So we listed that factor pair here under the radical. So we keep them in the radicals because you want to be clear that you're just breaking this down, right? Once we do this, then we simplify. We said the square root of 4 gave us 2. All right, and of course, the square root of 5 doesn't give us a whole number, so we're going to leave that there. And then we just bring it down as 2 square root 5. All right, and then once you get into the groove of this, it's super simple. It's very straightforward. All right, so that was example 1A in your workbook. We're going to go ahead and take a look at example 1B, and where we have the square root of 72. So of course, what are we going to do? We're going to kiss it. We're going to keep it super simple. So if we go ahead and list our factors, we have 1 times 72. We have 2 times 36. We have, does 3 go into that? 3 times 24. 4 times what? 18. 5 doesn't go. 6 times 12. 7 doesn't go. And then 8 times 9. All right, so we want to look at this factor list and decide what are the perfect square roots. So I know I have 1, 36, 4, and 9. So the key is we always want to choose the largest root. When you don't choose the largest root, what happens is you can simplify it down, but it's not going to be in the simplest form, and you'll end up doing extra work. So you always, of course, want to bypass that. So our largest perfect square root is going to be 36. So this is the factor pair that we're going to use. So remember, when we break it down in terms of factoring, the perfect square always goes first. So we're going to say 36 and the square root of 2. Of course, we're going to rewrite that as multiplication. So we're going to multiply those together. And then we're going to simplify. The square root of 36 is 6. And we're going to say times the square root of 2. And then we know when we multiply a whole number times a root or a radical, we just stick them together. So that's going to be 6 root 2. Got it? It's not too shabby, right? So we're going to go ahead and move into practice 1, where you guys can see if you actually have the skill down packed. All right, so we have the square root of 96. Okay, so of course, the very first thing that we're going to do is we are going to list the factors of 96. And in this case, we have 6 factors. So we're going to say 1 times 96. We're going to say 2 times 48. We're going to say 3 times 32. Does 4 go into that? Oh, 4 times 24. 5 doesn't go. 6 goes 16 times. 7 doesn't go. 8 doesn't go. I think it's 9 times. Nope. Something's missing. 8 does go. 8 times 12. All right, so I have 1, 2, 3, 4, 5, 6. All right. All right, now we're going to underline our perfect square. So we have 1, we have 4, and we have 16. So of course, what we're going to do, keep it super simple. Factor down which number or which set includes the largest perfect root. 16. So we're going to use 16 and 6. All right, so we're going to do the square root of 16 first. Perfect square always goes first. Here goes second. I'm going to go ahead and simplify. The square root of 16 is 4 times the square root of 6. All right, and we know when we do a whole number times the root, we just stick them together. So that is going to be equivalent to 4 root 6. And that's it. That's how you simplify radicals that do not have a coefficient. So of course, from the top, we always are going to kiss it. We're going to keep it super simple. First things first, list your factors. If you know your factors really well, you don't have to list them, but it makes it easier to see where we are. Once we list our factors, we need to identify what the largest perfect square root is. Then we're going to rewrite that particular factor pair using roots. And then from there, we just simplify down and you'll have your final answer. And again, this is an example of simplifying radicals without a coefficient.